Hey everyone, welcome to AI for Engineers channel. My name is Ali, and if you're here, it means you're interested in applying modern data science technique to the real life data sets. Now, while you're here, please click on the subscribe button and hit the like button as well. So for our first session, we are going to look at the SpaceX Falcon 9 first stage landing. So we want to determine if the first stage will actually land, and we want to determine the cost of the launch as well, because this information can be used if an alternative company wants to bid for a launch. And we want to use multiple machine learning pipelines, the most familiar and popular ones. So as you can see, I included GIFs of several unsuccessful landings that completely destroyed the launch site. But one of the reasons that SpaceX was able to actually bid so much lower than other competitors was the fact that they were using the uh, basically broken line site. So first we import all the necessary Python packages. Again, this channel is not a sort of intro to programming or anything. We just want to dive into the real life challenges and the projects and the databases themselves. So I skip these parts, and you can see that we have the first database here that has the some locational details and serial number of the Falcon 9 booster version. And you can see right at the end, the class feature is what we are interested in. Zeros means an unsuccessful launch, and 1 is a successful launch. And in another dataset, which has a lot more columns than the original dataset, we have all the information that we want to use as basically input to our dataset. And we use one-hot encoding method in order to translate all the text inputs that we had. So as I mentioned, we assign from the two databases that we had the output, which is the class, meaning successful, unsuccessful launch, and the rest from the second dataset to the X. And we standardize the data. We split it by a factor of 20% to train and test. And this is a small sample of tests just to show you that these are all 0 and 1s. So the first method that we use is log regression and or logistic regression, and we use grid search in order to find the best hyperparameters with CV equal to 10. And we can see it's doing a pretty good job of giving us 85% almost accuracy. And from the confusion metrics, we can actually see on the testing dataset that from the landed ones, basically it predicted 12 landed successfully. Now we have again 12 true positive and 3 false positive. Second method that we are using is called support vector machine, which is again another popular machine learning algorithm out there. And we can see all the details that the grid search cross-validation methods chose for us amongst the existing kernel. For example, it chose sigmoid as the best one. And we can see the accuracy of the model is 85% roughly. And again, we can see it does a similar job to the first model that we trained. The third model that we look into is a decision tree model. And in the decision tree model, we actually have a max depth of 14. We use cross entropy for the criterion, and we have a split size of 10. The machine learning model here does not perform as well as the two other models that we had, and we can see that in the accuracy of the testing dataset as well as the confusion metrics, which is actually predicting one of the rockets that landed as not landing, which is not what you want. And the last model that we look into is K nearest classifier, and the best estimator uses 10 number of neighbors, and the p value of 1, and we can see that it does perform identically to the two first model that we had. Now, if we want to visualize the results, we can see exactly the KNN, SVM, and the logistic regression perform the same. Although decision tree performs better on the training dataset, that actually leads to overfitting on the testing dataset, which is not appropriate for our real life projects. And we can see the results here more accurately in the table view. So for choosing between all these four models, it's up to you as a data scientist to choose between KNN, whichever you're familiar with the most. My go-to is always to go with that, and we can see actually here that the logistic regression is the second best based on the very similar results that we have. SVM and KNN perform the best in training and testing. The second place goes to the logistic regression, and at the third place we have a decision tree model. So this was our very quick first session, and in the future sessions I will post more in-depth videos, and we will go through deep learning models and use a more advanced technique to analyze real-life data from where we corrected. I forgot to mention one thing, and that is if you want to explore the data for yourself, these are the links for the data which are available to public. Don't forget to hit the subscribe button and hit the like button as well. Thank you so much. Have a good day.